Right, we're back again. Once again, balancing equations. These ones are combustion reactions. I'd just like to give a couple of shout outs before we get started. Gus Mansfield, I hope you appreciate the thumbnail. Gus told me if I wanted to lift my channel up to get better than Mr. Crabtree's, I needed exciting thumbnails with things like epic in the title. So, Gus, I did listen. Thanks for your advice. You must be a classic YouTuber. Today we're looking at probably what I reckon the most difficult of chemical reactions to balance. They're combustion reactions. Now there's two here. One at the top is going to be very easy to balance, but the second one is going to be a little bit harder, and we need to use a little bit of a technique. So first off, let's talk about what a combustion reaction is. Well, it's basically burning something. In most cases it'll be a hydrocarbon. So this is called a hydrocarbon because of course it has hydrogen and carbon in it. Anything needs to burn in the presence of oxygen, and it will always produce these two products, so carbon dioxide and water. Now we can see that it will produce both in both of these particular equations. It's one of the ways in which we recognise one of the 6 basic chemical reactions, which is a combustion reaction, as we said. So how are we going to go around balancing this equation? Well, once again, we need to break everything down to its elements. So we've got a carbon, we've got hydrogen, and we've got oxygen. So carbon, hydrogen, and oxygen. Make sure, of course, that we keep them in the same proportion each time. So there's 2 carbons over here because, of course, of the number 2. And on this side, of course, there's 4 hydrogens. And to finish off, 2 oxygens on that side. So that side of the equation is pretty easy. We do need to be careful on this side when we look at oxygen, though. So there's only 1 carbon on this side. If we look at the hydrogen, there's 2. And if we look at oxygen here, we actually see that there's 2 here, and don't forget about this little one over here, which makes 3 in total. So 2 plus 1 makes 3. So as we look at it, we can clearly see that it's not balanced for carbon. So what I'm actually going to do is start off with that. What I'm actually going to do is every time I balance one of these, I'll leave this oxygen here until the last. So I'm going to put a 2 in front of this, so that I can balance out those 2 carbon. But of course, as we can see, that 2 will also affect this oxygen. So we're going to get 4 oxygens here plus another one, which gives us 5 oxygens. So we've managed to balance it for a carbon. So the next thing that I would start to do is look at hydrogen, of course. So we can see here that hydrogen has 4, and on this side it's 2. So the number we need to put here is, of course, 2. So 2 times 2 will give us 4, and of course we'll now have 2 oxygens plus the 4 that we had before here, which will give us 6 oxygens. So we've got 2 carbons, 4 hydrogens, 4 hydrogens, 6 oxygens, but only 2. And that's why I leave this one till last, because if I put a 3 here, 3 times 2 will give us the 6 that we need, and we can say that the equation is balanced. So it's always good to leave that oxygen to be the last thing that you actually work with. So we have a look here. This is a combustion reaction because once again we've got our hydrocarbon, our oxygen, and producing carbon dioxide and water. So if we have a look, we just start off exactly the same. C, H, and O. Okay, and on this side, C, H, and O. So we get 2 carbons, 6 hydrogens, and of course 2 oxygens. On the other side, we've only got 1 carbon here. We've got, 2 hydrogens, and of course, once again, don't forget that little O that's sitting there. So 2 plus 1 gives us 3. So if we start with this, well, we're going to do almost exactly what we did at the start. We're going to balance for carbon. So we're going to put a 2 here, and that's going to give me 2 carbons, and 2 times 2 oxygens, which is 4, plus another one, which gives us 5 oxygens in total. So when we go to balance for our hydrogen, we've got 6 over this side and only 2 here, so we need to put a 3. And 3 times 2 gives us 6, and of course that changes our oxygen. So we've got 4 plus 3, which gives us 7. And this is the problem, because I can't put 3.5 over here. It's just not how we do it. I can't have half an oxygen molecule, for instance. So I've got a real problem when I end up with an odd number on this particular side. So how do I actually do this? Well, the trick is what I'm actually going to do is double everything. I'm going to leave this oxygen alone, but I'm going to put a 2 here, which is going to give me 4 carbons and of course 12 hydrogens. Now, if I double this to a 4, that'll give me 4 carbons. and I double this from a 3 to a 6, that'll give me the 12 hydrogens. So everything is in proportion here. But watch what happens, because 4 times 2 gives me 8 oxygens here, plus another 6, which gives me 14 oxygens. Now notice that I've changed from an odd here to an even number. And of course, if I want to make 14 oxygens on this side, then I actually need to times this 2 by the number 7. Now notice that this 7 that we had here is the number that's going to come out in front of my oxygen there. And so that of course gives me 14 oxygens, and I can say, yep, tick, everything is balanced. So the trick with any combustion reaction when you end up with an odd number down here is just to double everything. Leave this till last, of course, but double these 3 and it'll change this odd to an even. And that's how you balance a combustion reaction. But guys, I don't want to take up much more of your time. I hope you're enjoying these videos. Miss Moore's going to be placing some maths videos for you. So make sure you watch them and make sure that you're doing those balancing equation sheets. Rightio. Thanks, Gus. I hope you like the thumbnail.